Hello everyone, today I want to show you my homework for exercise 2.4. Firstly, this is the title of my homework. Write a C hash to control C++ language by adjust voltage. Before we start, let's look at the hardware we need. The main part are one Arduino Uno development board. This is the brain of our project. One LED, we will turn it on or off, and one photoresistor. This sensor reads light and changes voltage. One breadboard to connect all ports easily. Several dopant swivels to set electronic between parts. You can see the Arduino board in the picture. It has many pins for connecting wires. Some for digital signals like the LED, and some for analog signals like the photoresistor. A hardware connection. Let me show you rules. LED connection. The positive pole, the longer leg of the LED connects to Arduino's digital pin 2. The negative pole, shorter leg, connects to the 220 ohm resistor first. Then the other end of the resistor connects to Arduino's ground pin. Photoresistor connection. We use voltage division circuit here. It helps us read the voltage correctly. One end of the photoresistor connects to Arduino 5-volt pin, give power. The other end connects to the 10 milli ohm resistor. Then the resistor's other end connects to ground. The point where the photoresistor meet connects to Arduino analog pin A0. This pin reads the voltage from the sensor. Arduino uses code based on C++. The code has two main functions, setup and loop. Setup runs only once when Arduino is turned on or reset. It internalize hardware like setting pin mode and start serial communication to talk to the C hash program. Loop runs over and over again. It's listening for command from the C hash program where the serial port and does what the command says. Let's look at the code. Line 1 to 2. We define pins as a variable. Let pin is 2, let on pin 2, and let sensor pin on the A0. This makes it easy to change pins later. Line 4 to 7 setup. We set the LED pin to output mode so Arduino can set power to it. We also start serial communication with a baud rate of 96000. This is like a language speed that must match the C hash program. Line 9 to 27 loop. Arduino checks if there's a command from C hash. If yes, it reads the command and acts. If the command is LED, it flaps the LED state on become off become on. If command is voltage, it reads the photoresistor value 0 to 1, 0 to 3, converts it to voltage 0 to 5 volts, and sets the voltage back to C hash. There's a 100 millisecond delay to keep communication stable. Let's focus more on pin definition and the setup function. Pin definition line 1 to 2. We use constant because this pin number don't change by giving them names. We don't have to remember pin 2 every time. If we want to use the different pin later, we just change this number once. Setup function. The setup function runs once. Its job is to prepare Arduino. Pin mode LED pin output tells Arduino that the LED pin is for output, setting power. Without this, Arduino won't know how to use the pin. Several begin. 9600 starts several communication at 96000 baud rate. This is very important. If C hash use a different baud rate, they can talk. Now the loop function, this is where Arduino works no stop. Step 1. Check for commands. If several available, Arduino checks if there's a command from C hash in the several ports. If yes, it reads the command until it sees a new line. Checker the new line tells Arduino this is the end of the command. Step 2. Process LED command. If the command is LED, digital white, LED pin, digital red, LED pin runs. Let's break this down. Digital red LED pin. Check if the LED is on 1 or off 0. The thing flips the value. 1 becomes 0, 0 becomes 1. Digital white LED pin sets the flipped value to the LED, so its state changes. Step 3. Process voltage command. If the command is voltage, analyze rate. Read the photoresistor's value 0 to 1, 0 to 3. Dark light gives a high value, bright light gives a low value. Float voltage converts the 0 to 1, 0 to 3 value to voltage. For example, if the value is 512, voltage is about 2.5 volts. Several bright voltage sets the voltage number back to C hash. Delay 100. Wait 100 milliseconds. This stops Arduino from checking the several ports too fast, which could cause errors. Now let's move to the C program. It's a Windows Phone application with buttons and labels that talks to Arduino via the several ports. First, we need namespace. They let us use tools for several ports and forms. Using system, this is key for give us the several port class to control the several port. Other namespace like system, Windows forms help make the application windows, buttons, and labels. The main port is the form1 class. The application windows we declare several port object to talk to Arduino. We also have function for when the form load, when buttons are clicked, and when data is received from Arduino. Let's look at the several port object and the form loading event. Several port object and constant. Several port. This is our tool to set command to Arduino and receive voltage data. Default port COM11. We need to make sure this matches the port where Arduino is connected. We can check it in the computer's device manager. If it's COM12, we change it here. Form loading event. Provide wide form1 load. This runs when the C# application opens. For now, it just sets the label to ready to tell the user the application is ready to use. This button lets us turn the LED on or off. Here's how it works. In the button one click, function runs when we click the toggle LED button. We set several port first. Port name, default port like COM11. Bandwidth 96000 must match Arduino. Pretty no. No error checking for simple use. Date bits 8. Standard for several communication. Stop bits 1. Tells the end of the date bit. We use try check to hand errors. Tries to open the several port, set the LED command. Remember, Arduino need it to know the command ends. Close the port. The label update to LED state tangled to show success. Catch. If there's an error, like the port is busy or the port number is wrong, it shows us message. For example, error port COM11 is in use and updates the label to tangle field. Important, all several portmeters must match Arduino. If not, communication fails. This button lets us read the photoresistant voltage. The function is button to click. Try block. We create a new several port object with the same portments port band rate. We open the port, set the voltage command. So we should add to, but the code idea is to set the command. The label updates to tell the user it's working. To catch block, if there's an error, for example, port notified, it shows an error message and sets the label to read fields. Not We don't close the port immediately here because we need to wait for Arduino to set the voltage date. We will close it later in the function. When Arduino sets voltage date, the function runs. Here's what it does. Several port SP is several port sender. Gets a several port object that received the date. String date SP read instance reads all the date in the several port before. This is the voltage value from Arduino. This invoke. This is very important. The several port use a background third, not the same third as the application's UI. If we change the label directly, the application will crash. Invoke switch to the UI third so we can safely update the label to show the voltage. Port close. Now we close the several port since we got the voltage date. Let's understand how C hash and Arduino talk. Serial communication. Communication carrier. They use a USB virtual serial port like COM11 and follow the UART approach. The USB cable connects Arduino to the computer, so it travels through the cable. Parliament agreement. To talk clearly, they need the same rules. Bearer date 96000 if one use 1920000 and the other 96000 date becomes glabbered, like speaking too fast or too slow. Instruction format. C hash sets commands LED or voltage. Arduino sets back voltage as a number string. Use divisor. C hash is the master. It sets commands first and waits for Arduino's response. Arduino is the slave. It waits for commands that watch asks and never sets date unless C hash asks. Now let's see how to use the project step by step. Step 1. Toggle the LED. Make sure Arduino is connected to the computer and the C hash application is open. Click the Toggle LED button. The label shows LED state tangled. Look at the Arduino board. You will see the LED turn on or off. It flips each time you click. Step 2. Read voltage. Click the Got Voltage button. First, the label shows reading voltage. After a short time, it shows the voltage, for example, 2.5 volt. To test the photoresistor, cover the photoresistor with your hand. Voltage goes up. Shine a bright light on it. Voltage goes down. Click the button again to see the new voltage. Important precaution. First, upload the C++ code to Arduino first using the Arduino. If not, Arduino won't understand the C hash commands. Check default port in C hash. Make sure it's same as Arduino port in Device Manager. Now let we look this video. This is all my answer. Thanks for your listening. Goodbye.